Good evening, everyone. Hello, everybody. Students, hello, Naru. Hope you're all doing good. Students, today let us continue with current electricity. ఇంతకు ముందు కూడా current electricity మనం చేసాము, but we are revising it. Revise చేసినప్పుడు we'll go through the concepts also. కానీ క్వశ్చన్ ఆన్సర్ మెథడ్ లో రివైజ్ చేస్తున్నాం స్టూడెంట్స్. న్యూమెరికల్స్ ఉంటాయి, దాని న్యూమెరికల్స్ వచ్చిన కాన్సెప్ట్స్ డిస్కస్ చేస్తాము. All right, so let's get started. And any doubts you have got, please feel free to express your doubts. ఏ డౌట్స్ ఉన్నా మీరు ఎక్స్ప్రెస్ చేయండి. All right. All right, so here's the first thing to do. Let us understand what is rate of flow of electric charge. It is nothing but current. So charge flown in a particular time interval is current. Conductor. Unit is ampere, or also represented as A. Current in a conductor is due to the flow of electrons. Electrons flow outai, then that is what is called current. Conventional current lo manam positive charges flow outai anukunnamu, but it is found that electrons is the flow of not of positive charges. All right, negative charge electrons flow outai, and that is called current. But we consider to be opposite to the direction of flow of electrons. So two directions ఉన్నాయి students. ఒకటి conventional current, ఒకటి electronic current. Electronic current is in the direction of electrons. Conventional current is opposite to the direction of electrons. Alright, ఎందుకంటే ముందే పాజిటివ్ చార్జెస్ ఫ్లో అవుతున్నాయని ప్రిజ్యూమ్ చేసుకున్నారు, తర్వాత తెలిసింది అది నెగిటివ్ చార్జెస్ ఫ్లో అవుతున్నాయని. సో ఆ కన్వెన్షనే కంటిన్యూ చేసుకున్నారు. ముందు ఫాలో అయ్యే రూలే కంటిన్యూ చేసుకొని they still follow the same rule. Conventional current follow chesi will solve the problems. All right, and charge of one electron is nothing but 1.6 into 10 power minus 19 coulomb. And charge is equal to current times time, or from the same equation వచ్చింది మనకి current is equal to charge per unit time. ఆ equation నుంచి charge is equal to time into current. All right, again just to mention, charge of an electron is 1.6 into 10 power minus 19 coulomb. Now let's look at the fundamental law of electricity, Ohm's law. What is Ohm's law? At constant temperature, the current in a conductor is directly proportional to the potential difference applied across the conductor. Ante, if I is the current and potential difference V is applied across the conductor, then I have V is proportional to I. All right. And a cause effect law చూస్తాం students. So don't worry about, don't think much about it. It's actually V proportional to I. అన్ని క్లారిఫై చేస్తాము. Just follow me closely. That proportionality constant in తెచ్చుకుంటే, that is R. V is equal to IR, where R is the resistance of the conductor. All right. So at constant temperature, the current in a conductor is directly proportional to the potential difference applied across the conductor. So from there I get V is equal to IR, where R is the resistance of the conductor. Let us look at first question, students. Certain light bulb has a resistance of 480 ohms. When lighted, how much current will flow when connected across 120 volts? So the question ఆలోచించండి students. Ohm's law based with the question A. So B is equal to IR. Just think about it. Okay, Lokesh already has an answer. Good, great. You can type your answer in the chat. Aditya, Nitin, and Shrestha. Good evening, everyone. You can type your answer in the chat box. Think about it. And this is ohms, students. I'm sorry for this thing. It's actually ohms. So what do I get? I use the equation V is equal to I times R. Required to find the current I when resistance is, yes, excellent. 120 volts is equal to 3 into 480. I is equal to 120 by 480. So it is 1 by 4 amperes or 0.25 amperes. So let's look at the answer. Yes, it's 0.25. All right. Students, tappu pote tappu em ledu. What is important is you make an attempt. Attempt చేయండి స్టూడెంట్స్. అటెంప్ట్ చేస్తేనే మీకు కాన్ఫిడెన్స్ డెవలప్ అవుతుంది. And that is very important for examinations. All right. Confidence is very important for examination, students. It is confidence is everything actually. కాన్ఫిడెన్స్ ఎలా డెవలప్ అవుతుంది? అటెంప్ట్ చేస్తే హార్డ్ వర్క్ చేస్తేనే డెవలప్ అవుతుంది. All right. Look at the next one. The second unit of charge. Ampere, coulomb, volt, ampere. What is the SI unit of charge, students? You can type your answer in the chat box. Yes, Nitin has got an answer already. Good. That's right. Good, Nitin. Students, don't worry if you don't know the concepts or మర్చిపోయి ఉంటారు, that's okay. మీరు ఎలాంటి డౌట్స్ ఉన్నా మీరు మెసేజ్ చేయండి. Alright, message your doubts in the group. We will design our session accordingly. We'll design our class depending on your doubts also. We'll clarify, see to it that your doubts are clarified. మీకు ఎలాంటి డౌట్స్ ఉన్నా పెట్టండి. We are going with the question and answer pattern, question answer method లో వెళ్తున్నాము. But if at all you have got any doubts, you please message to the number 7337285228. All right, so that we'll design our session accordingly. All right, here's the next one. In current electricity, the particles moving are photons, electrons, protons, or neutrons. We talked about this a while ago. What is it moving? Photons, electrons, protons, or neutrons? Okay, Lokesh has got an answer. Good. Nitin, good. Yeah, go ahead. Lokesh, Nitin. Right, Sahiti. Okay, Ayan is still in the previous question. Ayan, that's correct, but we are in the next question, Ayan. Go forward. All right, that's right, absolutely right. Electrons is absolutely right. Let's go forward. In an electric circuit, ammeter is always connected in series, parallel, either way, series sometimes, and is or parallel depending on the nature of the circuit. series sometimes or parallel sometimes, depending on the nature of the circuit. Ammeter ఎలా కనెక్ట్ చేస్తారు? Alright. Current through the element కనుక్కోవాలంటే I'll connect the ammeter in series with the element. Let's say I've got an element like this. I want current through this one. So I'll connect an ammeter in series with this. Let's say I want current through this resistance. And I'll connect in series with this resistance. I want current through the battery. I'll connect it over here. Right? So we connected in series, students. Right? Let's go forward. So it's series. Good. Yes, Nitin, Swati, Ayan, Sahiti, Lingaya, Lokesh. Excellent. In series combination of resistors, potential difference remains constant. PD and a potential difference. Current remains constant throughout the combination. Current changes through the circuit. Nothing can be said. Yes, Nidhi, Ayan, Sahiti, Nitin, Swati. You're all right. So in series combination ఏమవుతుంది అని అడుగుతున్నారు. Series combination of resistors, what happens? Is it potential difference which remains constant or current remains constant throughout the combination? Series 2 resistors ఉన్నాయి అనుకున్నాం series లో. R1, R2. What battery? రెండు series లో ఉన్నాయి. Right? Why do I say they're in series? This current through this one, which is entering this one element, is entering through this element also. Same current I. Whatever current is flowing through R1, same current is flowing through R2. But potential difference across R1, V1, across R2, V2, that's not same or doesn't remain constant across the elements. With time it remains constant, but V1 is different from V2. But I1 is same as I2. So I1 is equal to I2 is equal to I. Alright, so let's see. So current remains constant throughout the combination. Alright, let's go for the next one. What is the unit of electric power, electric energy, potential difference, electric current? What is the unit of electric power, electric energy, potential difference, electric current? Friends, in Mali చెప్తున్నాను, we are doing revision, so don't be scared or don't feel intimidated థింకింగ్ కి ఇది ఎలా అవుతుంది మాకు అర్థం కావట్లేదు అలా అనుకోకండి. అర్థం కావట్లేదు అంటే మీరు మెసేజ్ చేసి ఏది అర్థం కావట్లేదు స్పెసిఫిక్ డౌట్ అంటే స్పెసిఫిక్ డౌట్ మెసేజ్ చేయండి. మేము ఫాలోయింగ్ సెషన్స్ అలా డిజైన్ చేస్తాము సో దట్ యువర్ డౌట్స్ ఆర్ క్లారిఫైడ్. ఆల్రైట్, సో డోంట్ వరీ, it is just a question answer method of revision. This will also help for your exam, but we will also do the concepts కూడా చేస్తాము. All right, so what's the answer for this? Okay, Arvind, Lokesh, Swati, Nitin, Shishikant, Ayan, Nidhi. All right, these are all students have answered. Let's see. It's electric energy. An electric heater uses 5 amperes when connected across 220 volts. Determine its resistance. Ohm's law used change, students. An electric heater uses 5 amperes when connected across 220 volts. Determine its resistance. So how do we do this? We apply Ohm's law. So let's say I've got a heater, heat and in represented with a resistor symbol. When connected across 220 volts, current it consumes is 5 amperes. So I'll get V is equal to IR, which implies 220 is equal to 5 times R. R is equal to 220 by 5, 5 fours 20, 5 fours 20, which is equal to 44 ohms. All right. Yes, Arvind, Nithi, Lokesh, Swati, all of you are right. Good, excellent. Students, you're already good. Excellent. Let's go forward. And that's absolutely right, students. Nithi, Nitin, Arvind, Lokesh, Swati, you're all right. Absolutely right. Others are also mentioning, answering, but they're still in the question. They are a little behind us. All right. So that's why I'm getting different answers now. I mean, previous answers now. So, and that's absolutely right answer, but we are a little ahead now. Please go forward. All right, look at this. Calculate the resistance of length 180 meters of silver wire with cross-section area of 0.3 meter square. The resistivity of silver is given as 1.6 into 10 power minus 80 ohm meter. All right. So how do we do this? We use the formula R is equal to rho L by A. Rho icharu, L icharu, A icharu. In proper unit substitute cheste, you'll get the answer. Would you like to try? So resistance is proportional to length, inversely proportional to area. Proportionality constant is resistivity. So R is equal to rho L by A. All three are given, required to find R. So let's see, 1.6 into 10 power minus 80 into 180 divided by area. 0.3 into 10 power minus 6, because that's millimeter square. I have to convert that into meter square. So it's just 10 power 8, students, not 80, right? It's 10 power 8. My bad. Okay. Resistivity of silver is 1.6 into 10 power minus 8 ohm meter. Yes, and you are right. Your your answers are absolutely right. Nithi, Arvind, Lokesh, Swati, Shashikant. Students, don't worry if you don't know this concept of resistivity. We will clarify this concept also. Chestamu, but right now, it's only for today or some sessions like this. We are going with question answer method. We will also do the theory. Sorry now, so don't worry that theory is not being done any other Anko Kandi. Theory will also be done. But if you give us inputs saying A doubts and specific doubts, aim doubts and we will design our sessions in a better way so as to address your doubts. All right. So what do we do? This is 3, 10 power minus 7. This goes on top, 7, 660, 8. So 1.6 into 10 power minus 8 into this gets cancelled out, sorry, plus 7. So I get 1.6 times 6. That is nothing but 6636. 63616 9.6 ohms. So that's nothing but 9.6. Supposed to be 9.6 ohms, students. All right. Look at this. I've done the calculation here. 1.6 into 10 power minus 8 into 180 divided by 0.3 into 10 power minus 6. This can be written as 3 into 10 power minus 7. 10 power minus 7, 10 power minus 8, it's cancelled out. What remains is 10 power minus 1. 3 and 180. 180 divided by 3 is 60. 60 into 10 power minus 1 is 6. So 1.6 into 6 is 9.6. All right. A wire of resistance R is cut into n equal parts and twisted together to make it single wire. Calculate the resistance of the resulting wire. A wire of resistance R is cut into n equal parts of purchase arrow, and they are twisted together to make it a single wire. Calculate the resistance of the resulting wire. Now, to do this, you will have to understand what is series and parallel, students. I'll explain what is series and parallel. Okay, Nitin, Lokesh, Srinitya, Aditya Pavan, Ayan, Nitin, Arvind, Lokesh, good. Gauss, good students, good. You're all right. Absolutely right. I really appreciate your attempts. So let me just tell you what is series and parallel, students. I'm waiting for your answers. Student D, he says wire resistance wire ఉంది n equal parts of divide చేశారు. Let's say 3 parts. These 3 parts are now connected like this. Each total is R, should be R by N, R by N, R by N. And if this is R by N, R by N, R by N, and so on, this is also R by N. What's the equivalent resistance of this parallel network? What is asking indirectly. All right, he has not given us a network. All right, he has not given us a network, but he has described in sentence that you have to convert it into a network and understand whether it's in series in parallel. Now let's see. If I've got one effective resistance is 1 by R effective is equal to N by R plus N by R plus and so on n times N by R, which is nothing but N into N by R, which is nothing but N square by R is 1 by R effective. So R effective is nothing but R by N square. So తగ్గిపోతుంది. If initially the wire resistance was R, if I cut it into N parts, and join it in parallel fashion. Yes, Shashikant, Srinitya, Ayan, Nitin, Arvind, go ahead, go ahead. Yes, Nitin is absolutely right. Ayan is right. Yes, it's fourth. Fourth option is absolutely right. Resistance of n identical resistances are parallel join cheste, it is R. If these are connected in series, what will be the equivalent resistance? Alright, parallel గా జాయిన్ చేసినప్పుడు n resistors ని R వచ్చింది నాకు. So equivalent resistance of n resistors, n identical resistors parallel గా జాయిన్ చేసినప్పుడు నాకు R వచ్చింది, క్యాపిటల్ R. వాళ్ళని ఆ రెసిస్టర్స్ ని సిరీస్ లో జాయిన్ చేస్తే ఎంత వస్తుంది? Alright, so let each resistance be X. X ఉంది అనుకుందాం. So there are n such ఇలా ఉన్నాయి. So 1 by x plus 1 by x plus 1 by x and so on. N terms like this, 1 by x, n terms is equal to 1 by r. I'll get x from here. So n by x is equal to 1 by r. So r is equal to x by n. Now required is x is equal to nr. X is equal to nr. Required ఏంటి? x లాంటి రెసిస్టర్స్ n కనెక్ట్ చేశాను, సిరీస్ కనెక్ట్ చేశాను ఇప్పుడు. సో ఇది nr, ఇది nr, ఇది nr, the NR and so on till n terms. So how much will that be? NR plus NR plus NR so on n terms is my required answer. X, capital X, or effective, R effective. So I'll have n square R is my answer. Here you've gone wrong, students. That's okay. That's okay, students, but it's very important that you correct yourself. ఇప్పుడు వరకు అన్ని కరెక్ట్ చెప్పారు. This one you've gone wrong, that's okay. All right? It's not third, it's second option, students. All right, n square R. మళ్ళీ చెప్పాలంటే చెప్తాను. But otherwise, if at all you have got any doubts in your series parallel concept, you let us know. We will design a session specifically to address your doubts. All right. Okay, let's go for the next one. When one bulb is removed from a series circuit, the other bulbs do not glow brightly, same glow. ఏమవుతుంది? ఒక బల్బ్ తీసేస్తే let's say what bulbs. Okay, Shashikant. All right. All right, Swati. Yes, one. For this, it's absolutely right. Do not glow. Do not glow. I don't even have to explain this. Good. Excellent. Yes. Okay. I just would like to revisit this question, students. ఇది ఒకసారి క్వశ్చన్ చూడండి. Let us understand this question again. It will take a minute. Okay. here. Yes, Anaram, Aditya, Ayan, Arvind, Nitin, all of you are right. All of you are right. Excellent. Okay, now let me just quickly tell this to you. It will take a minute, students. I'll not take more than a minute. My time starts now. Look at this. I've got n identical resistors. Let each resistance be X. They are connected in parallel. Anadu. So 1 by X plus 1 by X plus 1 by X, so on, n terms vargu is equal to 1 by R effective, which is R. Now, if these are connected in series, ఏమవుతుంది? X plus X plus X plus so on, n terms. So nx వస్తుంది now. Required answer is nx, Re. కానీ R, X in terms of R కావాలి నాకు. So here n by X is equal to 1 by R. So X is equal to nR. If I substitute this over here, required answer Re, effective resistance in series is n times nR, which is n square R. All right. That's exactly a minute. So I hope you have understood. That's why we get n square R, not nR. అదే R ఇండివిజువల్ రెసిస్టెన్స్ R ఉందనుకోండి, దెన్ n ఐడెంటికల్ రెసిస్టెన్స్ సిరీస్ లో కనెక్ట్ చేసినప్పుడు nR వస్తుంది. రైట్. బట్ హీ సెడ్ n ఐడెంటికల్ రెసిస్టెన్స్ ప్యారలల్ లో కనెక్ట్ చేసినప్పుడు క్యాపిటల్ R ఉంది. అయితే ఇండివిజువల్ రెసిస్టెన్స్ ఇవ్వలేదు, ఇండైరెక్ట్లీ ఇచ్చాడు. ఒక స్టెప్ చేస్తే మనకి ఇండివిజువల్ రెసిస్టెన్స్ వస్తుంది. అండ్ దెన్ వెన్ దోస్ ఇండివిజువల్ రెసిస్టెన్సెస్ ఆర్ కనెక్టెడ్ ఇన్ సిరీస్, హీ ఈస్ ఆస్కింగ్ హౌ మచ్ ఇస్ ద రెసిస్టెన్స్. రైట్. All right. Resistivity of a conductor increases with area of cross section, increases with length, decreases with length in decreases with decrease in length, remains the same. How does it depend on area and length అని అడుగుతున్నాడు. ఇది చూసాం, మనం ఫార్ములా చూసాం. బట్ హీఈస్ ఆస్కింగ్ రెసిస్టివిటీ, నాట్ రెసిస్టెన్స్. Resistivity of a conductor increases with area of cross section, increases with length, decreases with decrease in length, remains the same. Students, any specific doubts you have got, please message us to 7337285228. All right, we'll design our sessions accordingly. But we'll see to it that your concepts are clear. Yes, the answers are pouring in, and the answer is supposed to remain the same, students. Resistivity is independent of length or area of cross section, students. All right, resistivity is independent of area or length. Resistance increases with length, students, but resistivity doesn't. All right. Now look at this. Look at the other question. Resistance of a metallic conductor increases with increase in temperature, increases with decrease in temperature, decreases with increase in temperature, remains constant. All right, Shashikant. All right, Shashikant. Okay, so answer is increases with increase in temperature. right? Let's go for the next one. Resistance of a conductor varies proportional to length, directly proportional to length, inversely proportional to square of length, directly proportional to length. All right. So how does resistance of a conductor vary? Length vary చేస్తే resistance ఎలా vary అవుతుంది? We know that it's directly proportional to length, right? So let's go forward. It's directly proportional to length. A formula ఏముంది? R is equal to rho L by A. ఒక రెసిస్టర్ ఇలా ఉంది. ఏరియా ఆఫ్ క్రాస్ సెక్షన్ A ఉంది. లెంత్ L ఉంటే రెసిస్టివిటీ rho ఉంటే R is rho naught L by A. Okay, let's go for the next one. Heat produced in a conductor carries, heat produced in a conductor carrying current is directly proportional to square of current, directly proportional to square of resistance, directly proportional to current, inversely proportional to time. All right. So heat produced around the, yes, good. Okay, if I'm not writing anything, students, formula ఏం రావట్లేదు, రాయట్లేదు. ఇప్పుడు I'm just asking you heat produced in a conductor carrying current. Okay, I'll choose another color instead of red. I'll choose yellow because that's brighter. Okay, and this will be seen. Sure, I'm sure. All right. So the answer is directly proportional to square of current. Heat is proportional to I square R, directly proportional to resistance of the conductor and square of the current. Right. Let's go for the next one. This is a good one, students. This is a manchi question. A uniform wire of resistance R is bent into form of a circle. What is the equivalent resistance between the endpoints of the diameter? ఇప్పుడు కనిపిస్తుంది కదా అక్షయ్, ఇస్ దట్ ఓకే? All right, let's look at this. What's happening? What's the question? Circle only. Yes, Swati, that's right. Swati, think again. Circle ఇలా ఉంది, diameter ఇలా ఉంది. I think green, yellow is the best color, students. Green to కనపడదు. I'm just checking. Okay, now total resistance is R, right? Complete resistance is R. So semicircle resistance ఎంత ఉంటుంది? R by 2. సో ఇది కూడా R by 2 ఉంటుంది. పైన R by 2, కింద R by 2. దీన్ని స్కీమాటిక్ ఫామ్ లో డ్రా చేస్తే R by 2, R by 2. So there is nothing but parallel between AB. So between AB, I want to find RAB. So 1 by RAB, because they are in parallel, is 2 by R is 2 by R, which is nothing but 4 by R. So RAB is nothing but R by 4. Yes, Sri is right. Akshay, Arvind, Nitin. Nitin, think again. So it's R by 4 students. I hope this is understood. I'll go for the next one. When is series parallel concept use చేసాం ఇక్కడ మనం parallel of two resistors. ఇంకా స్టూడెంట్స్ ఒక షార్ట్ కట్ ఏంటంటే if you have got X in parallel with X, effective resistance is X by 2. Or if there are N such resistors, X, X అలా N ఉన్నాయి, then your effective resistance will be X by N. ఇక్కడ ఏముంది R by 2 and R by 2 are in parallel. So R by 2 by 2. సరేనా? So R by 2 by 2 is R by 4. దిస్ విత్ ఎక్స్పీరియన్స్ మీకు వచ్చేస్తుంది, బట్ విల్ డూ మోర్ సచ్ ప్రాబ్లమ్స్. ఇలాంటి చాలా ప్రాబ్లమ్స్ చేస్తే మీకు ఎక్స్పీరియన్స్ వచ్చేస్తుంది. బట్ లెట్స్ గో ఫర్ ద నెక్స్ట్ వన్ నౌ. A wire of resistance 180 ohm is bent to form an equilateral triangle. The resistance across any two vertices is, and this is not two students, it's ohms. Now look at this. This is an interesting question. I've got an equilateral triangle like this. 180 on the total. So each side will be 60 ohms. Do you all agree with that? Students, any doubt with the question? Okay, equilateral triangle form అవుతుంది. Resistance, total resistance of the wire is 180. The resistance across any two vertices is అని అడుగుతున్నాడు. So let's say I want resistance across these two vertices. A, B. ఎలా చేస్తాము? ఇది C అనుకుంటే AC and CB are in series. These two are in series. These two are in series. That is in parallel with AB. So all right, go ahead, students. Go ahead. Continue your answer. Try చేయండి students. 260 and 60 are in series, and that is in parallel with options ని మర్చిపోండి students. Just get to the answer because that is 180 ohms or 18 ohms is the question. All right. So forget about the answers, forget about the options. You can just simply think about what are we doing. ఇక్కడ ఈ టూ రెసిస్టర్స్ ని సిరీస్ కనుకొని దట్ సిరీస్ ఈక్వలెంట్ వచ్చాక దట్ ఈస్ ఇన్ ప్యారల్ విత్ దిస్ రెసిస్టర్. సో ఈ కాన్సెప్ట్ మల్టిపుల్ కాన్సెప్ట్ వస్తున్నాయి. సిరీస్ అండ్ ప్యారల్ బోత్ టుగెదర్ వస్తున్నాయి ఈ ప్రాబ్లమ్ లో. Yeah. So this 18 ohms students, it's not 180 ohms. At 18 ohms students, I just now calculated, it's 18 ohms, not 180 ohms. Yes, Arvind is correct, Shashikant is correct, Gauss, great. Nitin, Zafar, all right, okay. Akshay, Srishalam, Shashikant, Swati. All right, that is 18 ohms students, not 180 ohms. All right, my bad. So it came out on the 6, 6, 6. So these two should be 12 in parallel with 6. So 12 and 6 parallel on time the students. 1 by R equivalent is equal to 1 by 6 plus 1 by 12, which is nothing but 3 by 12. So R equivalent is equal to 12 by 3, which is equal to 4 ohms. All right, I hope you have understood. ఒక వైర్ ని ట్రయాంగిల్ షేప్ లో టర్న్ చేశారు, బెండ్ చేశారు, రైట్. టోటల్ రెసిస్టెన్స్ వాజ్ 18. సో ఈచ్ ఈక్వల్ ట్రయాంగిల్ సైడ్ ది ఏమంటే ఉంటుంది, 6 ఉంటుంది. 6 and 6, 6 3 is 18. The resistance across any two vertices అంటున్నాడు. So if I take these two vertices to be A and B, AB మధ్యలో 6 plus 6 ఉంది, 12 ఉంది. Third side is 6, so 12 is in parallel with 6. So parallel formula use చేస్తే I'll get 4. All right, if you want me to go slower, you let me know. But what is important is మీకు అర్థం అవ్వాలి, that's important students. నేను కంప్లీట్ చేయడం ఇంపార్టెంట్ కాదు. Right, all right, let's go for the next one. According to Kirchhoff's first and second laws, which quantities are conserved? Charge and potential difference, current and potential difference, current and energy, charge and energy. First law and second law is nothing but conservation of these two quantities, respectively. Charge and potential difference, current and potential difference, current and energy, charge and energy. Think this is just a conceptual question, students. So the answer is charge and energy. All right. In the first law, charge is conserved. Current, KCL, current, Kirchhoff's current law. Yes, Nitin is correct. Swati is correct. Arvind, Shashikant, Ayan, Zafar. Good that you're all attempting. Yes, Nitin, that's absolutely right. Let's go for the next one. A piece of wire is stretched to double its length, then its new resistances will be half the original value, will be the double the original value, will be quadrupled, will decrease by 4 times than the initial value. Okay. Now let's see what's happening here. The wire is stretched to double its length or not. Then its new resistance. Double అయినప్పుడు length, area same ఉండదు కదా, right? See, initially length L ఉంది, area A ఉంది, length L ఉంది. Length double అయినప్పుడు ఏరియా తగ్గిపోతుంది. AX అనుకుందాం. This is 2L. వాల్యూమ్ సేమ్ ఉంటుంది. ఇక్కడ వాల్యూమ్ ఎంత ఉంది, A into L. ఇక్కడ వాల్యూమ్ ఎంత ఉంది, AX into 2L. When I equate these two volumes, A into L is equal to AX into 2L. Cancelled out. AX will be equal to A by 2. అంటే ఏరియా హాఫ్ అయిపోతుంది. If length is doubled, area is half. Now what is the formula? R is equal to rho 2L by A by 2. 2 by L to the, look at the numerator. Rho L by A into 4. Rho L by A is previous resistance. So new resistance will be 4 times initial. So it will be quadruple. Students, length double అయితే resistance double అయితే ఏరియా సేమ్ ఉండి లెంత్ డబుల్ అయితే అప్పుడు రెసిస్టెన్స్ డబుల్ అవుతుంది. బట్ ఒట్టి లెంత్ డబుల్ అయింది కానీ ఏరియా సేమ్ లేదు కదా. ఒక వైర్‌ని స్ట్రెచ్ చేస్తే ఏరియా తగ్గిపోతుంది. సో ఇట్స్ క్వాడ్రుపుల్. ఆల్ రైట్ శ్రీనిత్య. All right. So let's go for the next one. I hope you have understood this. ఒకటే ఫార్ములా యూజ్ చేసాము rho L by A. Okay, let's go for the next one. Resistance of 3 ohm and 6 ohm are connected in parallel. All right. Sorry, students, it's ohms. All right. Just a second, I'll just change this. This is see a resistance of 3 ohms and 6 ohms. Ignore this mistake, students. All right. Focus on the subject. 3 and 6 are connected in parallel, he said. Now, this combination is connected in series with a resistance of 2 ohms. Between A and B, what is the equivalent resistance is asking. So, R, A, B, any or not. ఎలా చేస్తాము ఫస్ట్ ప్యారల్ రిడ్యూస్ చేసుకుంటాం ఎక్కడైనా ముందు ప్యారల్ రిడ్యూస్ చేయాలి స్టూడెంట్స్ దెన్ చెక్ ఇఫ్ దట్ ఈస్ ఇన్ సిరీస్ విత్ సంథింగ్ యూ కెన్ సింప్లీ యాడ్ వాట్ ఇస్ ఇన్ సిరీస్ బట్ ప్యారల్ అలా కాదు ఫస్ట్ ప్యారల్ రిడ్యూస్ చేసి ప్యారల్ ఎఫెక్టివ్ ఈక్వివలెంట్ కనుక్కొని దెన్ యూ గో ఫర్ అడిషన్ విత్ సిరీస్ సో 6 and 3 in parallel ఏంటి R 1 by R is equal to 1 by 3 plus 1 by 6 అది ఎంత ఉంటుంది 3 by 6. 1 by R is equal to 3 by 6. Implies R is equal to 2 ohms. Right. Now this is 2 ohms now. So this is equal to A నుంచి start అయ్యి this is equal to 2 ohms and another 2 ohms is connected. Now 2 and 2 in series is nothing but 4. So answer should be supposed to be 4. It is 4. All right. Students, 6 and 3 are in parallel. I got that as equivalent as 2. That 2 is in series with 2. సిరీస్ ఉన్నప్పుడు ఏం చేస్తాం మనం యాడ్ చేస్తాము రైట్ సో 2 plus 2 is 4. Have you understood this one? Have you understood this? We'll stop with this question, students. If you have understood, we'll stop with this. Yes, Nitin is right, Zafar is right, Ayan is right, Aditya is right, Arvind. Yes, excellent. Excellent. Shashikant is right. Okay, Shashikant is saying something. Option 4. Okay, great. That's right. Absolutely right. But I hope you have understood this. Students, the point over here is, ఏదైనా అర్థం కాకుంటే you please express yourself. You message us a doubt and then message చేయండి. We will design a session to address those doubts. All right. So do not think that your doubts are going to be left uncleared. Any doubts clear చేస్తాము. Only thing is you will have to let us know what the doubts you have so that we'll design a session, design a presentation for us to clear your doubts. All right. So please convey this to your friends as well. and do not hesitate to put doubts. Students, question is an expression of the quest within you. లోపల quest ఉంటే, a thirst for knowledge ఉంటే, you'll express your question. All right, so do not think that if you're asking questions you don't know. It means that you want to know, and which is very important. తెలియదు అని కాదు, తెలుసుకోవాలని ఉంది అని క్వశ్చన్ అడుగుతున్నారు, అందుకే క్వశ్చన్స్ అడగండి. All right, so that's all for today, students. See you again in the next session. Good luck.